Day 4 of solving equations. I started a little differently this time. This one right here is basically saying, hey, where does sine equal cosine? So basically on your unit circle, where does x equal y, right? And actually the only place that that happens is at pi over 4, where they are both radical 2 over 2, and at 5 pi over 4, where they are both negative radical 2 over 2. So if we are solving that from 0 to 2 pi, which we are, that is legit it. However, I did go through and kind of show you where the algebra comes from. You end up squaring both sides, and then you're going to subtract cosine squared from both sides, and then you're going to use a Pythagorean identity, and then combine like terms to get 1 minus 2 sine squared. Subtract 1, then divide by -2, so that's where you get your positive 1/2. And then when you take your square root, remember you're taking the positive and negative square root of it. And so the positive square root gives you pi over 4 and 3 pi over 4. The negative square root gives you 5 pi over 4 and 7 pi over 4. But again, it has to be like sine and cosine have to be the same. Like the left and the right, if we plugged them back in, the 3 pi over 4 and the 7 pi over 4 would not work. So I just wanted to show you the algebra behind it, but honest to goodness, guys, this right here is really, I mean, where does x equal y is what it's asking you, okay? All right, so then next one, oh, no, crap, sorry, didn't mean to do that. Just a blank sheet. There we go. All right, so tangent squared equals 3/2 secant theta. We are going to use a Pythagorean identity. So the Pythagorean identity here is secant squared theta minus 1, and that's going to equal my 3/2 secant theta. I am going to multiply everything by 2, so I don't have to deal with that fraction. So there we go, and there we go. So I've got 2 secant squared theta minus 2 equals 3 secant theta. And of course, this is going to be a factoring. So I'm going to subtract 3 secant from both sides. So I have 2 secant squared theta minus 3 secant theta minus 2 equals 0. And yes, again, guys, if you wanted to, you can, put it in terms of just plain old algebra. 2x squared minus 3x minus 2 equals 0. And factoring, they're small numbers, they're prime numbers, so they're easy to factor. So I got a 2 here and a 1 here. Problem is I got to get a -2, so one of them's got to be positive, and I need a -3 when I add them. So I'm going to do a negative here, because if I did outer times outer, that would give me a -4x, and inner times inner would give me a positive 1x, and that's exactly what I needed, okay? And so, of course, then from these two, I get x equals a -1/2, and x equals a 2. Remember, x stood for secant, so when I go do this, I'm going to switch back over to red. So I get secant of theta equals -1/2, and secant of theta, oopsies, equals a 2. Please remember, guys, secant is 1 over cosine. I say and a lot. I'm very sorry. -1/2. And when I cross multiply and divide to solve that, I would get cosine of theta equals -2. Doesn't exist. When you have just straight up cosine theta, it can only be in between -1 and +1, right? When you're not doing anything to it, when you're not looking at any, when we graphed that parent function cosine of theta, it just oscillated in between -1 and +1. So if you're not doing any other transformations to it, then it does not exist there. And then secant of theta here, 1 over cosine theta equals 2, technically over 1, cross multiply and divide, and you get cosine theta equals 1/2. So from there, you do actually get pi over 3 and 5 pi over 3. So you do get at least 2 answers. You just don't get anything from that first little, that first factor, I should say. I was going to say mini equation, but it's just a factor. All right, onward and upward. I'm going to add I'm going to add this to both sides. I'm going to add cosine 6 theta sine theta. There we go. That's what I was trying to say. All right, so when I add that to both sides, I have sine of 6 theta cosine theta plus cosine 6 theta sine of theta. That's actually going to be a sum or difference, right? It starts with sine, so I have sine there. Oh, that's weird. Okay. Sorry, like things moved around on the screen. I don't know if it'll show up on the video. So it's actually going to be, my u is going to be 6 theta. My v is just going to be a plain old theta. So that equals 0. So where does the sine of 7 theta equal 0? And this is kind of a little u substitution, right? So it's kind of a mix of both. So where does the sine of u equal 0? So what we do is, hey, that's actually at 2 places, right? 0 and pi, right? So if we had to write it as all solutions, right, we're going to write it as all solutions first because of this whole 7 theta thing here. Remember, when it's just a simple theta, whatever we find just works, right? But when we do this, we've got to write all solutions because we're going to end up basically dividing this by 7. So pi 2 pi n, and actually these guys are on a straight line, 0 and pi. So I'm just going to write it as 0 plus pi n. So I'm going to take that 7 theta and set it equal to that 0 plus pi n. And then when I divide, theta is going to be 0 plus pi over 7n. So I divided everything by 7, but 0 divided by 7 is obviously 0. So when I want my, come on now, there we go, there we go. When I want my answers from 0 to 2 pi, right, I have to do 0, that's the first one, and then I'm just going to keep adding 1/7. So it's 1 pi over 7, 2 pi over 7, 3 pi over 7, 4 pi over 7, 5, 6, 7 over 7, which is pi, 8 over 7, 9 over 7, good grief, 10 over 7, 11 over 7, 12 over 7, and, whoa, no, what am I doing? What am I doing? Stop that. And then 13 over 7. I cannot write 14 over 7 because 14 over 7 is 2, and I am not including 2. All right. Last one. I am going to subtract cosine of 5 theta from both sides. So I've got cosine of 3 theta, minus the cosine of 5 theta equals a 0. Guys, this one right here is one that we actually didn't get to before we broke for break. This is actually a sum to product. So you're going to have to flip your identity sheet over. Sum to product. Okay. So what it looks like is I'm going to take that and I'm going to rewrite it as -2 sine, and then it's going to be 3 theta plus 5 theta over 2 times the sine of 3 theta minus 5 theta over 2, and that's going to equal 0. Okay, so then I will have -2 times the sine of, all right, 3 plus 5 is 8 divided by 2 is 4 theta, right? And then sine of, and then it's going to be negative theta. 3 minus 5 is -2 divided by 2, so that's a negative theta. That equals 0. I'm dividing both sides by that -2 and that by -2 just to get it out of there. Okay, so then really what this is, believe it or not, very nice and simple for us. You've got, I'm going to write it in blue first, sine of 4 theta times the sine of negative theta equal to 0. So either your first factor equals 0, it's just the zero product principle is really what it is. So either sine of 4 theta equals 0 or sine of negative theta equals 0. Okay, I'm going to make this a little bit smaller so I can just keep going. All right. So for this one right here, it's, again, it's kind of the same idea. Where does sine equal 0? Well, that's at, we just did that one, so it was 0 plus pi n. So I'm going to take my 4 theta, right? I'm using u substitution. I'm just not showing all the work. So 4 theta equals 0 radians plus pi n. When I divide by 4, theta is going to be 0 plus pi fourths n. Okay. And then over here, the other one, oopsies, sorry. This is an even odd formula. It's on the front of your sheets. Sine of negative theta is negative sine theta equals 0. So sine of theta equals 0. And the only place that happens is at 0 and pi. So from this one right here, we get, in between 0 and 2 pi, we're going to get 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 3 pi over, good grief, 3 pi over 2, and then 7 pi over 4. And the nice thing is the 0 and the pi are already in my list, so you don't have to write them twice.